All right, Mr. Ahmed here for section 2.3 and 2.4. Our essential question for today is how do I solve inequalities? So in the previous lesson, we went over solving some one-step inequalities. The process is going to be pretty much the same, except for we're going to have more than one step. We're going to use the same exact rules as solving equations, except there's one exception. If I multiply or divide by a negative number on both sides, you must reverse the inequality. Hence, flip the sign. So if I multiply both sides by a negative, I'll have to flip it. And if I divide both sides by a negative, I will also have to flip it. So we're going to start off with some pretty straightforward ones. Our first one just says 2x is less than 23. Keep in mind, we want to isolate the variable. In order for us to isolate this variable, I need to get rid of the 2. 2 is being multiplied. The opposite of multiply is to divide. So I'm going to divide both sides by 2. I did not divide both sides by a negative here, so I do not need to flip the sign. 23 divided by 2 is 11.5. So x is less than 11.5. Again, on our graphing, you don't need to get real carried away here for me. Just put up where 0 is, and then we'll head over to 11.5. And in this case, it's an open circle at 11.5. I'm just going to write down when I went to 11.5. And x is less than, so I would shade to the left. The variable's less than. So all the numbers smaller than 11.5 will make the inequality true. 11.5 is not included. Next one. It says b over 3 is greater than or equal to negative 6. This one's a division problem. B is being divided. The opposite of divide is 2 times, so I will times both sides by 3. Now, notice, I am multiplying by a negative. I have a negative 6. However, I am not multiplying both sides by a negative, all right? I multiplied by 3 on both sides. That is a positive, so I do not need to flip the sign. The 3's cancel, and I have b is greater than or equal to negative 6 times 3 is negative 18. Put up the 0, head over to negative 18. I don't care where you put it. This is a or equal to, so a closed circle at negative 18. And b is greater than, so I'm shading to the right. Make sure it's nice and dark which way we're going. Got my arrow filled in. Next example. 12 is greater than or equal to negative 0.3k. So k is being multiplied. Opposite of times is to divide, so I need to divide both sides by negative 0.3. Divide negative 0.3. Now in this case, I divided both sides by a negative, so I am going to have to flip the sign. So 12 divided by negative 0.3 is negative 40. So I have negative 40. Flip the sign, less than or equal to now. K is isolated, K. So again, put up a 0. I'm going to go 10, 20, 30, 40. It's a closed circle. Now be careful when you read this one. This one says k is bigger because k is being eaten. So k is greater than, so I would shade to the right. And I also need to include that I went over to negative 40. All right, next one. Y over negative 4 is less than or equal to 1. So we have a division problem. The opposite of divide is to times. So again, multiply both sides. I am multiplying by negative 4. So do I need to flip the sign? Yes. I multiplied both sides by a negative, so I do have to flip the sign. And y is now greater than or equal to negative 4. Put up a 0. 1, 2, 3, 4. Negative 4. Closed circle because it's or equal to. Y is greater than, so we are shading to the right. All right, next page. Okay, a couple more challenging ones here. I see some variables on both sides. So our process is going to be the same. I need to round up the y's first. Again, I usually move the smallest variable 4y is smaller, so I'm going to subtract 4y from both sides to bring it over. Negative 3 less than or equal to 5 minus 4 is y plus 2. Subtract 2 from both sides. Negative 5 less than or equal to y. So, closed circle here on this graph. Put up my 0, 2, 3, 4, negative 5. Closed circle. Now let's read this one closely again. Start with y. Y is greater than. So if y is greater than, I shade to the right. Variable is greater, shade to the right. If the variable is less than, we would shade to the left. Got that one taken care of. Okay, next one. Looks like we are going to have to multiply, but keep in mind we want to add and subtract first. So I'm going to move the 5 first by subtracting 5 from both sides. 6 minus 5 is 1, greater than or equal to. Now this is tricky. Negative x over 3. Okay. A lot of people here might have wanted to add the 5. 5 is not negative, the 5 is positive. So to get rid of the negative and the 3, I will multiply both sides by negative 3. And I am multiplying by a negative, so I have to flip the sign. Negative 3 less than or equal to x. And put up my 0. Negative 3 is here. It is a closed circle at negative 3. And when I read, it says x is bigger. X is being eaten, so x is greater. Shade to the right. Go ahead and hit pause at this time and give the U-tries a shot. All right, hopefully you had some success here on these. I see the set of parentheses, so I'm going to have to distribute. 12 stays, less than or equal to. Negative 4 times 3 is negative 12c. Negative times a negative, change to a positive 24. Next step, subtract our 24. And we get negative 12 less than or equal to negative 12c. Divide both sides by negative 12 to undo the multiplication. I divided both sides by a negative, so I have to flip the sign. So negative divided by negative is positive 1. Greater than or equal to c. So 0. I'm heading over to 1. It is a closed circle. And it says c is smaller. C is less than. So I shade to the left with a less than. L to the left. Shader in. Got it. Okay. Last one here for number 4. Nothing to simplify on the left side, so I'm just going to rewrite 8a minus 6 is greater than 2 times 4 is 8a plus 2. Alrighty. Next step, subtract 8a, subtract 8a. Boy, they both cancel. They're gone. Negative 6 greater than 2. Is negative 6 greater than 2? I would say it is not. Since it is not greater, this inequality is false. There is no solution to the inequality. You may run into a case where you end up with something like, down on our summary, I'll go over this. You may end up with something like 8 is greater than or equal to 5. So the question would be, how often is 8 greater than or equal to 5? If both the variables cancel and you end up with something along those lines, all real numbers is the solution. No matter what, every number would be true. And the way that would look on the number line would be you just shade the whole thing. So you may run across one of those. All right, that's it for today. Have a good one.